Hey, in this section we're going to talk about implicit differentiation, and this is really important because now it lets us look at derivatives with equations where x's and y's are just running around all over the place, and in a situation where maybe it's really hard to get a y isolated all by itself. So excuse me, the implicit differentiation looks like this. Find the derivative by treating y as a differentiable function of x and differentiate both sides of an equation with respect to x using the different rules of differentiation, including chain rule. You will have to chain rule everything now, okay? Then we're going to solve for dy dx in terms of x and y together to obtain a new equation that will calculate the slope of a tangent line at any point xy on a graph. So that's a lot of mathematical calculus ease. Let's break it down into what we're talking about. We're talking about taking the derivative of both sides of an equation. And in that case, when we do that, what we're looking at is the derivative of this side right here and the derivative of this side right here, okay? But since that y now, we're going to take derivative of y and it's got a 2 on it, we're going to have to use the chain rule, okay? So if I've got that y squared guy, if I differentiate y squared, so d dx of y squared, okay, then I'm going to do 2 times y to the first power, okay, which is just basically 2y, times dy dx, okay, and this is implicit differentiation, okay, so whenever you have that y in there, you're going to have to take a derivative of the y. What does that look like? Dy dx, that's what it looks like. And then when I take the derivative of the x guy over there on his own, so if I just look at d dx of the x, that's just going to be 1. So what does this problem look like? Well, let's go ahead and write it out exactly what it would look like. On the left-hand side, after I take derivative of both sides, I have 2y dy dx. On the right-hand side, I've got a 1. And what we want to do is we want to find what dy dx is. We want to know what is that thing. So to finish this problem out, we're just going to divide both sides by 2y. And then I've discovered now that dy dx is equal to 1 over 2y. And I now have the equation to find the slope of a tangent line, instantaneous velocity. I know what dy dx is. All kinds of things now I can do from this point, okay? But there's going to be a y in my answer. So if they ask me to find the tangent line at a point, I have to know what x and y are so that I can find the correct tangent line. That's going to be the one big difference on this, okay? So this is really going to open our doors a lot more now for calculus. Let's look at another example on the next slide.